Right now, keeping food from spoiling is almost effortless. A refrigerator, a freezer, some plastic wrap, and suddenly a piece of meat that would have rotted within hours can last for days or even weeks. It's easy to take this kind of casual food preservation completely for granted, but early humans had none of this. No refrigeration, no plastic, no electricity of any kind. So how did they actually manage to keep food edible for any meaningful length of time, especially during lean seasons when a successful hunt or harvest needed to last considerably longer than a single meal? Let's dig into this properly because early humans developed a remarkably impressive range of preservation techniques, several of which remain in active use today, thousands of years later, in only slightly modified form. Let's start with the most basic underlying challenge worth understanding first, because it explains why food preservation mattered so urgently to early human survival. Fresh food, particularly meat and fish, spoils rapidly without any intervention, typically within a day or two under warm conditions due to the activity of naturally occurring bacteria and other microorganisms that break down organic material once an animal or plant is no longer alive and defending itself against this kind of biological breakdown. Early humans obviously had no understanding of bacteria or microorganisms in any scientific sense, but they would have observed through repeated direct experience that food left untreated for too long became inedible, sometimes dangerously so, while food treated using certain specific methods seemed to remain safe and edible for considerably longer. This basic observational pattern, refined and passed down across countless generations, forms the foundation of virtually every early preservation technique that eventually developed. Let's talk about drying first, because it represents one of the oldest, most widely used, and most geographically universal preservation methods available to early humans. Removing moisture from food, whether meat, fish, or various plant foods, dramatically slows down the microbial activity responsible for spoilage, since most spoilage-causing microorganisms require a certain minimum level of moisture to survive and multiply effectively. Early humans across an enormous range of different regions and climates independently discovered that meat or fish cut into thin strips and exposed to sun, wind, or a combination of both would gradually lose enough moisture to become remarkably stable and long-lasting, sometimes remaining edible for months under the right conditions. This detail is worth appreciating because it represents another compelling example of the pattern already explored extensively throughout other topics regarding independent human technological convergence. Populations across completely separate, unconnected regions, from parts of Africa to the Americas to various regions across Asia, each independently developed broadly similar drying techniques, arriving at strikingly similar practical solutions to the same basic underlying challenge, without requiring any shared cultural contact or transmission between these completely separate groups. Let's talk about smoking specifically now, because it represents a related but importantly distinct preservation method worth exploring in its own right. Beyond simply drying food through direct sun or wind exposure, early humans discovered that exposing meat or fish to smoke from a controlled fire provided additional preservative benefits beyond moisture removal alone. Smoke contains various compounds with genuine antimicrobial properties, meaning smoked food gained meaningful additional protection against the specific bacteria responsible for spoilage, beyond what moisture removal alone would have provided. Early humans obviously had no chemical understanding of exactly why smoking worked this way, but they would have observed, again through repeated practical experience across many generations, that smoked meat and fish seemed to last noticeably longer and resist spoilage more effectively compared to food that had only been dried without any smoke exposure involved. This detail connects to a broader pattern worth appreciating throughout the study of ancient practical knowledge more generally. Early humans frequently discovered truly effective techniques through pure trial and error and careful observation, techniques that modern chemistry has since confirmed actually work for real, measurable scientific reasons, entirely independent of the fact that the people who originally discovered and refined these techniques had absolutely no theoretical understanding of the underlying chemical or microbiological mechanisms actually responsible for their effectiveness. Let's talk about salting and its role in food preservation too, because this represents another critically important early preservation method, one already explored in considerable detail in other discussions regarding the broader history and significance of salt throughout human history. Salt draws moisture out of food through a process called osmosis, creating an environment where spoilage-causing bacteria struggle to survive and reproduce effectively. This meant salted meat and fish could be preserved for considerably longer periods than untreated food, and salt's effectiveness as a preservative, combined with its relatively widespread natural availability across many different regions, made it one of the most significant and consistently relied upon preservation methods across an enormous range of different ancient cultures and historical periods. Let's talk about fermentation next, because this represents a particularly interesting preservation method worth exploring specifically, given how it actually relies on deliberately encouraging certain specific beneficial microorganisms rather than simply trying to eliminate all microbial activity entirely. Fermentation involves introducing or encouraging specific beneficial bacteria, yeasts, or molds that consume sugars and other compounds within food, producing acids, alcohol, or other byproducts that create an environment considerably more hostile to the harmful, spoilage-causing microorganisms that would otherwise cause the food to rot. Early humans across numerous different cultures and regions independently discovered various fermentation techniques applicable to an enormous range of different foods, vegetables, dairy products, grains, and fish among them, each developing their own specific regional fermentation traditions using whatever raw materials happened to be locally available. This detail is seriously fascinating from a scientific standpoint because it means early humans, entirely without any understanding of microorganisms, managed to develop sophisticated techniques specifically designed to cultivate and encourage certain beneficial microbial populations while simultaneously suppressing harmful ones, essentially practicing a form of applied microbiology many thousands of years before anyone had any theoretical concept of what a microorganism even was. This represents one of the more remarkable examples throughout the entire history of ancient practical knowledge. Purely observational, trial and error-based technique, arriving at a solution so sophisticated that modern food science continues actively studying and refining fermentation techniques today, using considerably more advanced tools and theoretical understanding, but ultimately building on the same fundamental biological principles early humans first discovered and applied purely through patient, accumulated practical experience. Let's talk about cold storage and its early forms too, because this represents another significant preservation strategy worth exploring specifically, particularly relevant for populations living in colder climates or during colder seasons. Long before mechanical refrigeration existed in any form, early humans in colder regions discovered that food stored in naturally cold environments, underground pits, caves, or areas with consistent access to snow and ice, remained fresh considerably longer than food left exposed to warmer ambient temperatures. Some ancient and historical societies developed increasingly sophisticated methods for actually harvesting and storing ice specifically for this purpose. Cutting blocks of ice from frozen lakes or rivers during winter and storing them in specially insulated structures specifically designed to keep that ice from melting for as long as possible throughout the warmer months, providing a genuine, functional cold storage system many thousands of years before anything resembling mechanical refrigeration technology existed. Let's talk about fat and oil-based preservation methods too, because this represents another important, somewhat less commonly discussed preservation technique worth exploring. Specifically, various ancient cultures developed methods for preserving meat by submerging it in rendered fat, creating a protective barrier that helped limit the food's direct exposure to air and the airborne bacteria and spores that could otherwise cause spoilage. This particular technique proved especially valuable and widely used in certain specific regions and climates where drying or smoking alone weren't quite sufficient to reliably preserve food for extended periods, offering an additional, complementary preservation strategy that could be used either independently or in combination with other preservation methods already discussed. Let's talk about underground storage and root cellars too, because plant-based food preservation presented its own distinct set of challenges and solutions worth exploring separately from the meat and fish preservation techniques already discussed extensively. Various root vegetables and other plant foods could be stored for extended periods in cool, consistently humid underground storage areas, conditions that naturally slowed spoilage while helping to prevent the vegetables themselves from drying out and becoming unusably shriveled or tough. This technique, relying on the naturally stable, moderate temperature typically found somewhat below ground level, represents another example of early humans developing effective preservation strategies through careful observation of their natural environment, rather than through any active chemical or biological intervention applied directly to the food itself. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Let's talk about grain storage specifically too, because this became an increasingly critical concern once agriculture developed and grain surpluses became an important part of many ancient economies and food systems, discussed at greater length in other explorations of how agriculture reshaped human society more broadly. Properly drying grain before storage, then keeping it protected from moisture, pests, and rodents through various storage container designs, became an essential, highly refined skill within many ancient agricultural societies, since a poorly managed grain store could quickly become infested with pests or affected by mold, potentially destroying an entire community's carefully accumulated food surplus and creating an actually severe practical crisis heading into the following season. Let's talk about pemmican specifically, because it represents a particularly clever, well-documented example of combined preservation technique worth exploring in detail, developed independently by various indigenous peoples across North America. Pemmican involved combining dried, pounded meat with rendered fat and, frequently, dried berries or other fruit, creating a dense, calorie-rich food product that could remain stable and edible for remarkably extended periods, in some cases reportedly lasting years under proper storage conditions. This particular combination technique layered several preservation principles already discussed: drying, fat-based protection against air exposure, and in some versions, the natural preservative properties of certain dried fruits, into a single, highly effective, portable food product specifically well-suited to the demands of long hunting expeditions and extended travel where carrying large quantities of fresh food simply wasn't practical or possible. This example is worth appreciating specifically because it demonstrates the kind of sophisticated, deliberate food engineering early humans were capable of, carefully balancing preservation, portability, and nutritional density all at once. Developed entirely through generations of accumulated practical experience and refinement, rather than through any formal understanding of nutrition science or food chemistry, as modern science would define these fields today. Let's talk about freeze-drying techniques developed independently in the Andes Mountains too, because this represents another remarkably sophisticated ancient preservation innovation worth exploring specifically. Indigenous populations living at high altitude in the Andes Mountains developed a technique for preserving potatoes, known as chuño, that took deliberate advantage of the specific environmental conditions available at high altitude, alternating freezing temperatures overnight with intense sun exposure during the day. This process naturally drew moisture out of the potatoes through a combination of freezing and evaporation, producing a preserved product that could be stored for years without spoiling, representing an early, naturally occurring form of freeze-drying technology, a preservation method. Modern food science didn't develop industrially until many centuries later, using considerably more advanced and energy-intensive mechanical processes to achieve broadly the same fundamental preservation outcome that Andean populations had already achieved, purely through clever, deliberate exploitation of their own specific high-altitude environmental conditions. This example deserves particular appreciation because it shows early humans essentially reverse engineering, through careful observation and experimentation, a preservation process that would later be independently rediscovered and formalized by modern industrial food science, arriving at a truly equivalent practical outcome using nothing more than a sophisticated, deliberate understanding of their own local climate and environmental conditions, entirely without any of the mechanical or theoretical scientific tools modern freeze-drying technology eventually developed and relied upon. Let's talk about honey and sugar-based preservation too, because this represents another important preservation strategy worth mentioning specifically. Relying on a somewhat different underlying principle compared to most of the techniques already discussed. Honey's extremely high sugar concentration and low moisture content create an environment highly inhospitable to most spoilage-causing bacteria, a property various ancient cultures discovered and actively exploited by preserving fruit and other foods submerged directly in honey. This technique proved particularly valuable in regions and cultures with reliable access to honey, offering yet another example of early humans identifying and practically applying a specific natural substance's genuine preservative properties entirely without any theoretical understanding of exactly why extremely high sugar concentration and correspondingly low available moisture created such an effectively hostile environment for the specific bacteria responsible for causing food spoilage. Let's talk about the specific challenge of preserving dairy products too, because this connects directly to material already explored in other discussions regarding the broader history of dairy consumption and lactase persistence more generally. Fresh milk spoils remarkably quickly without any intervention, creating strong, immediate practical pressure toward developing effective dairy preservation techniques once populations began regularly consuming milk from domesticated animals. Various ancient dairy farming cultures independently developed cheese-making and yogurt-making techniques, both relying fundamentally on the same basic fermentation principles already discussed, deliberately encouraging specific beneficial bacterial cultures that produce lactic acid, which in turn creates an environment considerably more hostile to harmful, spoilage-causing bacteria, while simultaneously transforming the milk into a completely different, considerably more stable and long-lasting food product entirely. This detail reinforces an important point worth carrying through the rest of this discussion. Many of history's most significant food preservation breakthroughs weren't purely about extending a food's usable lifespan in its original form. They frequently involved actively transforming a highly perishable raw ingredient into an entirely different, considerably more stable food product altogether. Milk into cheese, cabbage into various fermented vegetable preparations, grapes into wine, each transformation representing a deliberate, sophisticated application of preservation principles that simultaneously created an entirely new, culturally significant food tradition in its own right, well beyond the original food's simple, unprocessed form. Let's talk about how climate and regional variation shaped which specific preservation techniques different ancient cultures actually prioritized and developed too, because this represents an important, recurring theme worth drawing out explicitly. Populations in hot, humid climates faced particularly urgent pressure to develop effective preservation techniques quickly, given how rapidly food spoils under warm, moist conditions, while populations in colder or drier climates could rely more heavily on simpler, more passive preservation strategies, like natural cold storage, or straightforward sun drying, given how much more slowly spoilage naturally occurs under these considerably more favorable ambient conditions. This variation helps explain why different specific preservation techniques became particularly dominant and well-refined in certain specific regions. Smoking and fermentation featuring particularly prominently in certain humid tropical and subtropical regions, natural cold storage and ice harvesting featuring particularly prominently in colder northern regions, each population developing and prioritizing the specific preservation strategies best suited to their own particular environmental circumstances and locally available natural resources. Let's talk about how these various different preservation techniques often got combined together too, because this represents an important, sophisticated dimension of ancient food preservation worth appreciating specifically. Early humans frequently combined multiple preservation methods together for maximum effectiveness. Salting food before smoking it, or drying food before storing it in a cool underground location, layering complementary preservation strategies together to achieve considerably more reliable, longer-lasting results than any single method alone would have reliably provided. This kind of combined layered approach reflects a really sophisticated practical understanding of food preservation, developed and refined through countless generations of accumulated trial and error, even without any formal theoretical understanding of exactly why combining these specific techniques together produced such reliably improved results. Let's talk about how food preservation capability actually reshaped broader human social organization too, because this represents an important, far-reaching consequence worth exploring before wrapping up. Reliable food preservation meant communities could successfully accumulate meaningful surplus, storing food from periods of relative abundance to help carry them through leaner seasons, droughts, or other unpredictable environmental setbacks that would otherwise have posed a serious, immediate survival threat. This capacity for meaningful surplus accumulation, made possible directly by effective preservation technology, likely played a significant role in enabling larger, more settled communities to develop and sustain themselves. Since a population's ability to survive lean periods without needing to immediately disperse or relocate depended heavily on having reliably preserved food reserves available to draw upon. In this sense, food preservation technology wasn't simply a matter of individual household convenience. It represented a foundational technological capability that helped make larger scale, more settled human civilization practically possible in the first place, connecting directly to broader questions already explored regarding the rise of agriculture and increasingly complex, settled human societies more generally. It's worth acknowledging honestly before wrapping up that these ancient preservation techniques, while remarkably effective by the standards of their time, still carried real limitations and risks compared to modern preservation methods. Preserved food could still occasionally spoil or become contaminated despite careful preparation, and without any scientific understanding of the specific pathogens involved, ancient populations had no reliable way to detect certain dangerous contamination before it caused serious illness. This detail is worth including for the sake of historical accuracy, since presenting ancient preservation methods as flawlessly safe and effective would overstate their actual reliability compared to modern food safety standards, even while still fully recognizing just how impressively functional and sophisticated these ancient techniques truly were, given the complete absence of any scientific understanding of the underlying microbiology involved in their development and refinement. Let's talk about how researchers actually study and confirm these various ancient preservation techniques too, because this connects to a familiar methodological challenge already explored regarding other categories of ancient technology relying heavily on organic, perishable materials. Archaeological evidence for food preservation comes from a combination of sources: chemical residue analysis on ancient storage containers and cooking vessels, physical evidence of storage structures like root cellars and grain silos, and careful anthropological comparison with more recent traditional societies that continued practicing similar preservation techniques into the period when researchers could directly observe and document their practices. This combination of evidence allows researchers to build a reasonably confident picture of ancient food preservation practices, even without any direct, physically preserved examples of the actual preserved food itself typically surviving across such an enormous span of archaeological time. Let's zoom out and pull all of these different threads together, because the full picture of how early humans preserved their food turns out to be considerably more sophisticated and varied than a simple assumption of primitive, limited technique could ever fully capture. Early humans developed and refined an impressively wide range of preservation strategies: drying, smoking, salting, fermentation, cold storage, fat-based preservation, and underground storage among them, each developed independently across numerous different cultures and regions, and each reflecting genuine, sophisticated practical understanding built through countless generations of careful observation and accumulated trial and error, entirely without any formal theoretical understanding of the underlying microbiological and chemical mechanisms. Modern science has since confirmed actually explain why these specific techniques work as effectively as they remarkably do. So the next time you casually toss leftovers into a refrigerator without a second thought, it's worth remembering that you're benefiting from an extraordinarily long history of accumulated human ingenuity, one that stretches back tens of thousands of years to early humans who had to solve the exact same basic problem, keeping food edible for as long as possible, using nothing more than careful observation, patient experimentation, and whatever natural resources happened to be available within their own specific environment and climate. Which leaves an interesting thought worth sitting with. If something as fundamental as food preservation required this much accumulated practical ingenuity and careful, patient experimentation to develop, entirely without any theoretical scientific understanding to guide the process, what does that suggest about the sheer depth and sophistication of practical human knowledge that developed and then, in many specific cases, was eventually lost or forgotten throughout history, long before anyone thought to formally document or preserve the specific reasoning and experimentation behind it?